Good evening, guys.
Good evening, sir.
So we'll be discussing the last assignment for the day. Of last week. So I'll give you 2 minutes time. Check your notes and tell me what are all the problems you didn't understand. I'll be solving only those problems. I'm not going to solve everything. Yeah, tell me, guys. Tell me the list of problems that you need help with.
Sir, I want the answer for the 11th one, sir. I'm not very sure. 11th one.
Okay, then
Third one, sir.
Sir, 10th one, sir.
okay, 10th I have marked. Then
Sir,
half of you, I think.
12 and
Yeah,
14, sir.
Sir, 13, sir.
14, sir.
Half of you are seeing the question paper now only, right? Well, 13, 14, next. Okay, I'm
Sir,
starting.
10th one.
Yeah, 10th I have marked.
26, sir.
Okay.
Sir,
May I know who asked?
27.
Okay, 27th. May I know who asked the third one?
Sir, me, sir.
Name?
Varun, sir.
Okay. Who asked the 10th one? Satyapriya. I remember two of them asking. Only one?
I did, sir.
Okay, 11th who asked? Nandakishore, right?
Yes, sir.
12th
Sir, I asked, sir.
name?
Supra, sir.
13th
Sir, I asked Sir Mokshit.
13th is by Moksha. 14th,
Supra, sir.
sorry, ma?
I asked the question, sir.
Shipra only, no?
So even I
Yes, sir.
didn't get 14, sir. Satyapriya.
Satyapriya. Okay, next. 26th who asked? Varun.
Sir, Varun, sir.
27th, somebody
Sir,
asked 26th.
Nandakishore, sir.
Nandakishore. So I hope you guys have read the question. I'll be doing it fast. So listen. Third one. So three concentric metallic spherical shells of radii R, 2R, and 3R are given the charges Q1, Q2, and Q3 respectively. It is found that the surface charge densities on the outer surface of the shells are equal. Then the ratio of the charges are. So sigma 1 is to sigma 2 is to sigma 3 is the same. So they all are same. Varun, tell me what is the formula for surface charge density?
Sir,
What
can
is
you
the
repeat
formula
it, sir?
for what is the formula for surface charge densities? I asked a simple question. What is the formula for surface charge density? What is the
Sir,
formula
I
for
don't remember it, sir.
Q1 divided by 4 pi r square is to Q2 divided by 4 pi into 2r the whole square is to Q3 divided by 4 pi into 3r the whole square is 1 is to 1 is to 1 is equal to 1. If I take this as k, then Q1 will be k into 4 pi r square. Q2 will be k into 4 pi into 4r square. And Q3 will be equal to k into 4 pi into 9r square. So ratio will be 1 is to 4 is to 9. This answer. Okay. Next. So 10th one. There is a uniform field of strength 10 power 3 volt per meter along y-axis. So electric field is equal to 10 power 3 J cap. They didn't say positive or negative. Okay, I'm taking it as positive. A body of mass 1 gram and charge 10 power minus 6 is projected to field from the origin along the positive x-axis with a velocity of 10 meter per second. Okay. Its speed after 10 seconds will be. Satyapriya. Satyapriya, answer this. If the electric field is like this and the particle is projected with a velocity v perpendicular to the electric field, what is the path taken by the particle? This I've told many times. Satyapriya, are you there or not? I'm not able to hear you. Make it fast. See, if I don't get a response, I'll put you in the waiting room. Is anyone able to hear what she's speaking? Give me a response in the chat. What is the path traveled by the particle when it is projected perpendicular to the electric field? Gayatri, you tell me. What is the path followed by the particle when it is traveling, when it is projected perpendicular to the electric field?
Sir,
Not sure. Hemant?
perpendicular.
No. Hemant? You have written the answer as 10 root. You have written the answer as 10 root 2. How did you get it?
Sir, I didn't submit, sir.
No, you, not you. Hemant. Venisha, that's not right. That is only for magnetic field. If a particle is projected perpendicular to magnetic field, it is circular. Particle is projected perpendicular to electric field. I've told this to you. If you go and revisit the concept when I explain magnetism and matter, there it will be there in your notes. Hemant, are you there or not? Please don't waste my time, guys. Venisha, that's perfect. If nobody is responding, I'll put you in the waiting room. I don't want in the class.
Sir, now you can hear me.
Yeah, I'm able to hear you.
Yes, sir.
I asked what is the path? What is the path?
Sir, I guess it will be along a straight path, sir.
No, it's not straight line. It's parabolic. Unless you know this, you will not get the answer. Okay, they asked what is the speed. So speed means you will calculate it like this. V is equal to u plus at. Okay. So you need to calculate the velocity along x direction as ux plus ax into t. If you see the acceleration in x direction is 0. So vx will be ux. It is constant, 10 meter per second. Similarly, when you calculate velocity along y, you write ui plus ay into t. Right? So Vy will be equal to Uy is 0 plus acceleration along y direction is Q into E divided by M into T. So what is QE? Q is what? 10 power minus 6 into electric field is 10 power 3 divided by the mass of the particle is 10 power minus 3.
Minus.
Into the time is 10 seconds. Okay, if you calculate this, so if you calculate this, you will get the value of Vy. Then the speed of the particle will be root of Vx square plus Vy square. Okay. That will give you the answer as 10 root 2. You calculate it
Okay, sir.
later. Okay, next. 11th one. Nandakishore, did you read the question?
Sir?
Did you read the question? 11th one? You only
Yes,
asked
sir.
no.
Yes.
So what do you understand? You tell me. You tell me
So
whatever
there's
you
a-
understand.
So there's a parallel plate capacitor of capacitance C connected to a battery of charged potential V.
Okay. By doing that, what will
there are
happen?
two capacitors. First one has a capacitance of C. Second one has a capacitance of 2C, sir.
Correct.
And the potential difference of the first plate capacitor is V and the other is 2V, sir.
Okay. So by connecting it
Uh,
across the potential source, what will happen? They'll get charged.
Charged.
So what is the charge on the first capacitor? It will be CV.
CV.
What is the charge on the second capacitor?
Sir, is it 2C into 2V?
Correct. Okay. Now when they are connected together, they will attain a common potential. V dash will be equal to Q1 plus Q2 divided by C1 plus C2. This is a formula. So Q1 plus Q2 will give you 5CV divided by C1 plus C2 will give you 3C. Cancel them. You will get 5C by 3. Okay. Now what is going to be the total energy? Total energy will be half C V dash square.
Half CV.
So half into 2C into V dash square. Take this V dash and substitute it in both the equations. The answer will come out as 25 by 6 CV square. That calculation I'm leaving it to you.
Okay, sir.
Shipra?
Yes, sir.
Yeah. So what do you understand from this question in the first place? An electric dipole consisting of charges plus Q and minus Q are separated by distance L in a stable equilibrium. Right,
Sir,
in uniform electric.
So the potential energy is the product of the distance and the charge, sir.
Okay.
Sir, I had a confusion.
Potential energy is not distance into charge. What is the potential energy
I
of
mean
an electric
potential. So dipole is. So won't they, since there are two charges, won't it be? Aren't we supposed to calculate it 2 times?
No need. This is a formula minus P vector dot E vector. So minus Q into 2L into E. This is the answer.
Okay, sir.
Sorry,
okay,
not
sir.
2L. Minus Q into L.
I had this.
Minus Q into L into. No. Q into 2A, right? 2A is the distance of separation between the charges.
Okay, sir. Since I got confused there, since two charges, I thought we have to calculate for each of them, sir.
No need. Mokshit, you tell me what is that you are. Yeah. Mokshit, you tell me what is that you understand from 13th question.
Sir, there are 2 point charges, sir, and those 2 points are P and Q, sir. They're arranged they are arranged like that, sir. Like they have given us, sir, points landing on perpendicular bisector on a line, sir, AB.
Okay,
so
there is.
Taking, charge of 5 mu from P and
There
Q.
is a charge small q which is moved along the perpendicular bisector. What is the work done? So how to
Work done,
approach?
sir. Sir, we can take like V equal to P by Q, sir. From there we can do, no, sir.
No, work done is 0 because there is an equipotential surface.
Okay, sir.
Fourteenth. I know this problem you guys can't do it. So V is equal to minus x square y minus xz cube plus 4. So E will be equal to minus dV by dr. right? So electric field along x direction is minus, I write it as dou v by dou x. This is called as partial differentiation, meaning the total electric field will be electric field along x direction times I cap plus electric field along y direction times j cap plus electric field along z direction times k cap. So I'll tell you for Ex, you guys tell me what you're supposed to do for Ey and Ez. Means you need to differentiate this V with respect to X. So if I do dou V by dou X, anything other than X should be taken as constant, even if it is Y and Z. So in this minus, so it is minus dou V by dou X. No, so minus of, what is the derivative of this? Minus derivative of x square y is 2xy. Because y is a constant, don't apply product rule. Minus, what is the derivative of xz cube? It will be only z cube. Plus derivative of 4 is 0. Okay. Using the same logic, tell me what will you do for dou v by dou y? Shipra, tell me. Minus of derivative of x square y should be taken as constant. So sorry, y should be differentiated. X square should be taken as constant. So you will get minus x square into, tell me. At least
dy
try.
by
Dy by dy. What is the derivative of y with
y.
respect to y? It is 1. Xz cube. Is there any y term in it?
No.
So this will be minus 0 plus derivative of 4 is 0. So this will come out as x square. Satyapriya, tell me what is minus dou v by dou z? Minus is there in the formula. So in x square y, is there any z term?
Sir, is it 3x square, sir?
Minus 3?
Not minus, sir. 3. Yes, sir.
No,
3x.
there is a minus here.
Okay. Then it
So
will
it is 3z square x.
x.
Okay. So this will become 3z square x. Now observe, pushing the minus sign inside, plus, plus, plus. So 2xy plus z cube I cap plus x square j cap plus 3z square x k cap. So this is answer. Okay, this method is called as partial differentiation. This kind of a problem is very rare that they will ask. But even if they ask, now you can handle it. Provided you understood. Next. 26th. Again, Varun only asked. So electric field intensity at a point is the strength of the electric field at that point. It is also defined as the force experienced by the unit positive charge placed at that point. Electric field intensity is a vector quantity. It is denoted by E. When placed within the electric field, the test charge will experience an electric force either attractive or repulsive. Varun, answer this. The electric field at a point is always what? So if you take an electric field at a point, will it be continuous? Will it be continuous if there is a point, if there is no charge at that point? Will it be continuous only if there is a negative charge at that point? None of these. Continuous means they're saying that these lines, is it going to be continuous or not? What is the
Sir,
answer?
option A, sir. Continuous, sir.
That's right. So electric field at a point is continuous. I'm sorry. So if I take this charge, if there is a charge at this point, then the electric field will get split. Actually, option should be B. It is not always continuous. It is continuous if there is no charge at that point. So if you're talking about a point, if you want to find the electric field at that point, then this electric field should have been only due to the source charge. If there is any other charge, it will become a test charge. So it will not be continuous. So the answer is, why? What is the meaning of continuous is because this electric field cannot pass through this charge. That is what they're trying to say. Okay, it is continuous only if there is no charge at that point. Next, a charge is distributed uniformly over a ring of radius A. Obtain an expression for the electric field intensity at the point on the axis of the ring. Hence, the points at larger distances from the behaves like a point charge. Okay, so if there is a ring, there is a positive charge given on the surface of it. You need to find the electric field at point P on the axis which is at a distance. Okay, they are given the hint. Points at larger distances from the ring, it behaves like a point charge. Means instead of taking this as a ring, if you take it as a point charge, what is the electric field due to a point charge at a distance x from it? This is a very simple question. What is the electric field due to a point charge at a distance x from it? Q divided by third. Force on an electron in a uniform electric field. Varun, tell me what is the relation between force and electric field? F is equal to Q into E. So charge is 1.602 into 10 power minus 19 multiplied with 5 into 10 power 4. So it should be somewhere around 1.6 into 5 is somewhere around 8. So 8 into 10 power minus 15. This should be. Actually, sorry, this should be the answer because electron is negatively charged. So minus 8 into 10 power minus 15. Now tell me, at a particular point, the electric field depends upon. At a particular point,
Sir,
the electric
test charge, sir. B, sir.
no, test charge will not come into picture. It depends
Then
only
it
on the. That's what I told you.
A,
No, the first.
sir. A, sir. Sorry, sir. A, source charge.
Four charges of the same magnitude and same sign are placed at the corners of a square, each of side 0.1 meter. Then the electric field intensity at the center is. It's
0,
based on
sir.
symmetry. Be 0 because it is based on symmetry. Yeah. 27th. So 27th is about a capacitance. Okay.
Yes, sir.
So 1 microfarad is equal to how much?
Sir, option C, sir, 10 to the power minus 6 farad.
Correct. The capacitance between two plates increases with, you know that
Sir,
capacitance.
option D.
Very good. Larger plate area and shorter distance between the plates. Reason? C should be directly proportional to.
And inversely proportional to D.
Correct. Capacitor stores which type of energy?
Sir, is it potential energy?
Correct. Electrostatic potential energy. This problem you need not do because the combination of resistor and capacitor is not there in your syllabus. So
Sir, I don't know this one, sir. I'm confused.
the force of attraction between the plates of a parallel plate capacitor. See, the charge on this plate is Q. The electric field due to the negative plate is sigma by 2 epsilon naught. Correct?
Yes, sir.
So force is equal to, I just use the formula Q into E. So Q is capital Q. Electric field is sigma by 2 epsilon naught. Q into, what is the formula for sigma? What is sigma? Sigma is surface charge density. How do you define surface charge density? It is Q divided by
2 divided by 4 pi r square.
it is A. Q divided by
Oh,
A.
yes.
So it will be Q square divided by 2 epsilon naught times A.
So it's option A, sir. Okay, sir. Clear. Thank you, sir.
Yeah. So that's it, guys. Any other doubts?
No, sir.
Okay.
No, sir.
No, sir.
Okay, then we can wind up.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.